So today it's gonna be lower the mic a little bit. It's gonna be a little bit different. We kind of have to finish a little fast because it's a midterm gonna be used in this room. So yeah, let's just get like right on to it. So this, nah, it's dark mode. Dark mode. Merge to sorted list. Okay. Okay. So this is an easy problem. We have two linked lists. They give us both heads of both linked lists, and we're supposed to merge them. These linked lists are already sorted like this. Yeah. Yeah. So, but that's fine. We have Frank watching in the stream. At least I heard. Yeah, it's a friend of mine from high school. But irrelevant information. We're going to sort two linked lists. All right? They're both already sorted. Yeah, it's an easy problem. So maybe you all done it. You haven't done this one. All right. You wanna? How do we start? I will go through it, but we don't have a lot of time. But there's a more efficient way of doing it. That's less memory intensive. You can do it in constant memory. What do you mean? No, 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 no. You're not offending. Hello. No, we don't want 1, 2, 4, 1, 2, 3, 4. We want a merging where the order after you add all elements of the list into one bigger list, they're in order. That's what we want. Okay, okay, okay. So we'll forget about array list adding. This isn't an array list. This is a linked list. There are two linked lists. You're given the heads. The head of one linked list and the head of another one. Hello. So you're given the head of one linked list and the head of another. One head is list one, the other one is list two. Right. So your job is to merge them. So if they're like this, so that they're kept in order. We can't use that. But what we do have a little bit of a hint up here, right? We have the class, we have the attributes val and next, right? You remember this? You don't remember this? Oh, it's linked list. It's linked list. It's a node. A linked list node. A list node. No. No, no, no. The value is the value of that current node. So for this one, it's one. That's two. That's four. Not an index. No indices and linked lists. So how should we start? Well, typically I would just make a dummy head to start with a dummy value. It doesn't matter what it is. I'm gonna put negative infinity or the lowest possible number. Whatever. What matters is that we're not gonna return dummy. We're gonna return dummy.next. So I'm gonna make it equal to dummy. So we're gonna make it. What is it? Yeah. But what is the point of it? What does it do? Just an idea. Yeah, it's a pointer. What's the point of the pointer? Right. We're pointing to a new address. right?
Right. Yeah.
Right. So it is going to iterate throughout what?
The dummy array.
No, it's not an array. It's a linked
A
list.
linked list.
A linked list. But yeah, we're going to construct the dummy linked list, which is going to be a combination of the two. But what's it going to do? What's it going to iterate over?
The list of addresses.
Yeah. Yeah. So both lists, right?
Yeah.
Okay. So we're going to check that list. Actually, I'm going to set A and B to equal list 1, list 2, just to make it, less writing.
Right.
A and B. What is this checking?
Well, we still have values in the linked list.
Not values.
Or addresses.
Well, yes, while A and B are not pointing to a null
Right.
thing, object.
Right.
So that's what that checks.
Okay.
So now we're here. We, of course, at the end, we're going to do it equals it.next. But before this, we're going to do something else.
We need to add it to the dummy.
Right. So what do we do? Which value do we add? A or B? How do we check which one to add? Yeah, exactly. So if A dot val is in B dot val, it dot next, I'm gonna set it equal to A. I'm going to move that one to the next one. Right. Okay.
Oh, I get it.
Hello. Else what?
Same thing, but with B.
Yeah, exactly.
Oh.
E equals B dot next.
Oh, and I see how this is constant.
Yeah, this is constant memory. So we're not using another array that grows. We're just using pointers.
Right.
We're just manipulating pointers. That's all we're doing. We're not creating extra memory. We're not needing an extra buffer. All right. Is that it? We done? Are we done? Carlos, do you know what we're doing?
Merge to sort of this.
Yeah.
How? I assume in numerical order, right?
Yeah. In ascending order. No, we're creating a dummy head and we're pointing the next one to the smallest of the two heads, and then we're just manipulating the pointers of the nodes. That's all we're doing.
That makes sense.
Yeah.
I think
We're done?
I think so. I mean, we're moving to the next value of the dummy array.
Yeah, which is the smallest head. All right. No, we're not done. That was the little gotcha there. It doesn't matter. I mean, if A is less than B, A is the next. But if B is equal to or greater, if B is less than or equal to, just it's B. Yeah. Yeah, it's the else. That's the else takes care of it.
I think, oh, you know what happened? It's that we ran out of values in A. So the while statement becomes invalid and it just keeps going.
No. If A runs out, then if A runs out, then the while loop stops.
So
Right?
up there, while A and or B, I think is a better condition.
No.
No?
That's actually the opposite of what we want.
Oh.
It's the opposite.
Let's see the last.
The rest of the other one? Yes, exactly. That is exactly what we want. If we still have A, right? Then it dot next, we want to set it equal to A. Else, it dot next equals B. That makes sense?
Yeah.
Yeah.
It's like the last ditch thing.
It's like the last check we need.
Yeah.
there.
So how come we can't do while A or B?
Because we want to stop when one of them runs out of values. Then the one that with the remaining values, we just add the head of that. And that's it. And that's next.
Because
Yeah, the rest are already greater than
yeah,
all of the ones in the other one.
and
So it doesn't matter. Yeah,
it'll break everything.
yeah, it'll break everything. So I'm actually gonna make this a little bit. These two lines, I'm gonna make it one. Equals A is A else B. Let me just see if that works. Okay, yeah. Yeah. So that was one lining it.
Wait, but that uses
Not really. No, last time I did that, we ran out of time.
more memory.
And we have a midterm here after this, so yeah, which I mentioned before. Yeah, so we have to move out of here a little sooner than usual. Okay, so there's this other problem. What's this? Next one. Which is a follow up to this one. I'm not going to do it. Joseph's gonna do it next time. Yeah, I'm not gonna do it. I'm just gonna prelude. Be like, yo. Yo. Oh. Okay. You weren't supposed to see that. But it doesn't. You guys probably don't remember. Oh, good. None of you were looking at it. Good. I'm glad. So there's this other problem, and it's merge k sorted list. So instead of merging just two, we merge k of them. So a variably length amount of sorted linked lists. So this is the follow-up to the other one. So what do you think you need to do to solve this one?
Well, for sure, we need to make a dummy link list.
Yeah, probably what we have to do.
For sure.
But maybe not. You could do that. And then what? And then merge it into like one dummy. That's a solution that you could do. However, and Joseph, you're gonna go over this, right? Yeah. There's a reason that's actually pretty inefficient. Because well, I'm not gonna spoil it too much. Actually, now I wanted to go over a different coding platform where you can do different types of problems, which is I'm getting to now. Let me just do Kattis. Kattis. No problems. All right. So Kattis is kind of like LeetCode, except well, you can actually have your name out there, and you can actually compare yourself with other people. So the best user is Ivan Petrov from Bulgaria. He has 9,900. That's his score. This guy's insane. This guy from Georgia Tech got 9,000.
University of South Dakota.
If you scroll down a little bit more, you see FIU. Of course.
No, yeah. I think the highest one is 800 for FIU. No. It's not on this list. Huh? Huh?
No,
Gian Giuseppe?
Yeah.
Hold on. I'm gonna go over our university. Okay, here's the rank list. So we are ranked 153 as a university. Huh? And yeah, our best one is 800. So we gotta catch up. What? What? Where am I? Where am I? I am on this, yeah. I am on this. Right, here's me. So yeah, yeah, this is recent. I was actually 3 on Saturday. So yeah, 3. Yeah, no, like my score was 3. So I was like, I wasn't even on here because I I failed to actually. There's a part of the registration in your settings where you gotta put your country, your subdivision, and your university. Otherwise, you don't register.
If you put Russia, your score goes up, right back up too.
um. Well, I prefer not to do that because I want to win the fairway. You know what I'm saying? So, oh look, and here's Lazaro. Oh wow, you did this weekend. You're number 6, dude. You got more than uh, Alejandro Paredes, dude.
Who's that?
He's in Facebook.
Oh,
He works in Facebook now. But
probably didn't do that many though.
yeah, you didn't do that. Right? You got 27.
Yeah,
Yeah, Demba, he's there.
Joseph.
No, this is the other Joe.
Azar's there too.
Oh yeah, Zar's got a lot. He's got a lot of points up there. But yeah. So you also get a lot of problems. These problems are a little bit different from leak code because they require a bit more effort from you in terms of input. You have to do that. You have to get the input yourself. They don't just give it to you and put it in a class and just test the class for you. No, you have to make it. So we'll do. Let me just do a really easy one just to show you what I mean. Okay, I'll do hello world. Hello world. Actually, there is no input. No, and if there's no input, then I'm not doing that. Okay. Yeah. So for example, actually, let me do. Yeah. You have to work on it outside. So actually, let me add another window capture. Give me a sec, guys. Code. Okay. All right. So don't mind this code. We're not gonna use this. Yeah. Okay. I think it's this one. Yeah, actually, we might go over Brexit. Probably gonna go over Brexit. What was the name of the problem? I think it was swap
Switch
digit swap. Okay, so I'm gonna call it new file swap.py. So I'm doing it in Python because it's faster. And let me see what else do I have to do.
You have to make it a function.
Wait,
Yeah, what?
you not do Brexit?
Not Brexit?
Yeah,
Why?
do it.
Oh, okay. So I'm not doing Brexit because he's.
Plus, that one's pretty hard, even though we haven't gone over graphs. Try to do something that we covered already.
Well, actually, I ended up not using a graph. I just made a.
You did use it in business list?
I'm not gonna tell you. But yes, I did actually use that. Yeah. So main. So we have the main function, right? Like in Java, we got main. Use main here too. And if name call main. This is just when you run your code in here, it makes it run faster. It's better than just scripting it. Okay, so I'm just gonna return just to get rid of that error. All right, so what's the problem asking you again? Digit swap. So Anne Britt Caroline has a safe with a 2-digit code. Occasionally, she types in the code too fast, accidentally swapping the position of the 2 digits. She asked if you could program her to check if not only the 2-digit code she entered was correct, but if the code was with the 2-digit swapped is also correct. Okay, so first step in her safe is to write a program that swaps the digit of a 2-digit code. The input goes from 1 to 9 without any spaces between. Output a line with the swapped 2-digit code without any space between the digits. You guys understand this? All right. So in Python, actually, before I continue, let me switch over to later. Yeah, stream sees it. All right. So you're getting a digit, right? So how do you get input in what? Yeah, 2 digits. Yeah. So all the input's gonna be correct. So you call it input. You say number equals input. All right. I mean that's pretty much it. So what do we want the number to be a number or a string? What makes more sense? A string. Do you guys agree? Should it be a string? All right, let me put it back. So you can do the reversal, right? I mean, it's a little bit extra work if you made it an integer and then you did that. Yeah. Yeah, just swap it. Yeah. So yeah, it's actually pretty simple. So I'm just gonna make it a string. So input returns a string. Let me actually just see. Yeah. So see up there, it's an input. Don't worry about that. But it returns a string, str. So number is of type string. So when usually they want you to print the answer. So I'm gonna print the answer in reverse order. Okay. So I'm going to. Do it again. Okay, 24. 2. All right. So I'm gonna copy all my code. Gonna submit. Make sure you got the right language selected. You select it here. Oh, actually, hold on. Yeah. Yeah, so make sure you switch to editor. Yeah, you got an editor here, but you can't test it. Language, make sure you have it set. Submit. And now it's going to run test cases. And if they all pass, get it. You get it accepted. Yeah. Linear. All in. Yeah. Like the string. It's just 2.
So something else that you want to watch is your input size and how many seconds you have
Yes,
to
you did.
get the answer correct.
Yeah.
Yes. By Joseph.
By Joseph.
So let's say, wait, can you go back to it?
The problem or the code? It's only 2, so it's a constant number 2. That's your input. And that's it. Yeah, so it doesn't matter. Just reverse the 2-digit thing. So this is an easy problem. All right. Difficulty is 1.2. Now let's actually compare that with. You want me to do Brexit? Did you solve it already? Oh, nice. All right. Oh, that's 2.5. That was not too hard.
Oh, look.
It's a game. Can the stream see it? Yeah, they can. All right. Just making sure. 2048. We know what it is. We know what it is. Input.
That's actually too complex.
Hold on. Wait. Oh, they actually give you a start.
Also, it gives you like a theoretical part of the board, and then you have to do an input and then update the board to act as if.
Wait.
You are just making the game here.
No.
Yeah, you're literally just making
The last line is the operation you did. So 0 is moving to the left, and then 1 is moving up, I think.
Yeah, so you're just making the game.
Yeah, but only for 1 move.
The input is
only
always
one
valid.
move,
Game
it's
state
still like-
28,
Yeah,
4
You just
integers,
have to scale it up.
16 integers. It's just one line you move to the right, left, or up or down,
Yeah.
right? Just one line. Okay.
Theoretically, you just keep calling it again on itself and just made the game.
Well, the input will be either 0, 2, 4, 8, 16 to 10, 24. So it ends at 2048. unlike the real game where it doesn't end at 2048. I think. Actually, what? Wait, does the game end at? It does?
Yeah.
I never got that
Only
far.
the knockoffs that like let you go higher.
I never got that
No,
far.
on 2048 you can keep going.
Oh, really?
You win at 2048, but you can keep going.
Oh, my friends are right over there. 14. Uh,
You want to make the entire game right now?
I mean, well, we're not making the game. Let's actually see what we're supposed to do. The input is a valid game state. So that means you're not losing. That each contains four integers and a 4 by 4. The jth integer in the jth line denotes the content of the cell located in the ith row in the jth cell. For this problem, all the integers in the input will be either 0, 2, 0 means it's an empty cell. A fifth line of input contains an integer 0, 1, 2, or 3 that denotes left, up, right, or down executed by the player. Output 4 lines with 4 integers each. 2 integers in a line must be separated by a single space. This describes the new state, right? So after you make a move. Yeah. This describes the new state. Again, integer 0 is an empty cell. Note that you can ignore that part of the 2048 puzzle where it introduces a new random tile with a value of either 2 or 4 in an empty spot. Okay, so yeah.
It's just the game without the extra adding the little block.
Yeah, without reactivating or whatever they use.
Okay, yeah, we're just gonna affect a little 2D array.
Yeah, I mean, look how on top the 2002 goes to 4 because like they swipe left or something.
Okay, so yeah, actually, yeah. So let's read the problem. So we got 0, right? 0 denotes left. So they move something to the left,
Yeah.
and it was the bottom.
Yeah, but it moves all the numbers
It's like
left.
pressing left in the game.
Yeah.
So
Oh, it does all of it.
Yeah.
Yeah, that's the thing.
I've it's been a long time.
Yeah, like
It's
it
been a long
moves
time.
all of the blocks left. So like on top it merges the 2 and 2, and it also merges the 2 1024s.
All right.
Oh, it's
Oh,
because
the numbers
you
have to
can't-
be the same.
Yeah, it has to be the same. So it's a merge.
It's agreed.
Yeah, it's just been forever. I was like 2014 or something. I don't know. Okay, so do we know? Make a new file. All right, 2048. Let me actually do the same thing that I did before. Just copy and paste this as well. So now the input is a little bit different. And it's okay if you all don't know the intricacies. Okay. All right. So we want the board, right? I'm gonna say board equals that, right? It's an array list, right? So for in range, what is it? 4. We do it 4 times. So this isn't the most efficient way of doing it. I'm going to show you a more efficient way, of course. Board dot append input. Okay. Yeah, they're going to give you the input.
Oh yeah.
Oh.
Yeah. They're giving you the board. So you're gonna append 4 lines. So input returns a line of input.
And then we go.
Yes. All right. Now, is there anything wrong with this? So what does this input return? Just the string of the line. Is that what we want? What do we want?
Actually, wouldn't you need 5 because you have to account for the 5th line, which is actually the move that you're
Oh
gonna
yeah. Well, we could just put that as a move equals the. I mean, actually, it doesn't even have to be an integer. I am going to move. Let me see. I won't. You know what? I won't worry about this just yet. Move equals int input. I'll leave it like that. Okay. So there's something wrong with this one. Yeah, it's a string. So how do we turn it into a list of numbers? Yeah. Well, we kind of like this, right? But we can't quite do that because it's a list. So here's what we do. We want the board is going to be a list of lists. Why is it a list of lists? Because each list is basically a row. So a list, we're going to map. I know. This is actually, right. Anybody have any questions about what I just did? Well, okay. Yeah. Okay. So basically, line 8 is I'm making a list off of, okay, so this is the map function, and a map has a function and an iterable, right? So int is a string, but when I split it, I'm going to turn it into a list of strings. And by default, the delimiter is going to be the space. So it's going to separate it into tokens. So A space B space C, in split, it's going to turn into a list of A, B, C. Make sense now?
And then we turn that into a list type.
Yeah.
And then
So
we append it to the board.
this is already a list. So it takes in an iterable, which is this list of strings, turns each of them into an int. That's what the map does.
Right.
Then turn that into a list again.
Right. Into the row itself.
Yeah. So it's basically the row of numbers.
Right. Okay.
That's what this does.
Yeah.
Now there's a more efficient way of doing this, and I can do it all in one line, which is complicated, but just kind of bear with me. Yeah, just bear with me, please. Just copy and paste this. That also
That
works.
makes sense.
This is a list comprehension, and it's much faster. Yeah, I know. All right. So now we have our board and our move, which is left or right, or
Yeah.
So now what do we do?
We can make I actually think a switch case statement would work amazing here. Because if we have a 0, then we move all the numbers left.
Right.
Or up or down or whatever.
Okay.
Right.
Yeah, the switch would work for them.
Hello.
Sorry, I was gonna class.
Nah, you're good, dude.
Actually, like thinking about moving everything within the matrix.
So we want to move all the zeros in a certain direction, right?
Yeah.
Yeah. So we can start by moving the zeros all to the end, and then after that, if we have to do a merge, we just do the merge.
I think we should
The zeros?
Hmm?
Moving the zeros?
Yes, we start by moving the zeros because those are the empty cells. So I am proposing. I mean, give me your ideas. But switch case. That's a good idea to know how to move it. That we move the zeros first and then we merge.
Oh, I actually
So we do it. We iterate by moving the zeros to. So if it's moving to the left, we move the zeros to the right. Does that make sense?
Yeah, that makes sense.
Yeah.
But then, like, let's say we have 2 and 2 together, and we merge them. We still have to append the 0, right? We have to make sure to do that, if I understood that correctly.
What do you mean?
So, like, we have the board, right? And we have 2 and 2. If we slide the 2s to the left, right? We have the 2s next to each other, like you said. We put the 2 on the left and the 0s on the right, right? Does that make
Yeah.
sense? But then we have to merge the 2s. Once we do that,
Um, well, it's a little bit.
What if we make like a conditional where we have the index of so like let's say we're moving from the right to the left, right, which is what zero is doing, right? We have all the numbers.
So if it's 0 or 2, it's left or right. But if it's not, if it's 1 or 3, which then we do the other thing.
Right.
All right. Please ask questions about this.
I get that part.
You get that part. Okay. Because this is gonna be all right. So this is going to be a left or right movement. So what we want to do is that we want to iterate.
Oh, I see what you're
Range 4. So we could do bubble,
bubble sort.
kind of bubble sort. I kind of want all the zeros to be on the other side. And why am I comfortable using bubble sort? Because your dimensions are 4 by 4. Yeah. I mean, I could probably isn't necessary. Mm. Yeah, so basically, so what I'm going to do is that I'm going to put them together. And then in another loop, I'm going to merge them. What? Yeah. No. If 2, 4, 2, 8, yeah, the 2s don't merge. If it's moving to the left or right, then no, that row, there's no merging. So, what's she thinking? If move equals 0. If move equals 0, we want to move it's left. So we want to move the zeros to the right.
Yeah, so we want to go from big to small.
Well, no, we just want the zeros to be put on one side of the board.
Oh, right. Okay.
Yeah. So I guess we could, yeah, I think I am just going to do that. Board. Actually, before I do that, if yeah, I have noticed that. For a problem like this, you might encounter a lot of nested stuff in there. Well, so for each row in the board, we're gonna move the zeros to the right. So if row equals 0, then we're gonna swap row I and row J. Okay, do you guys get this part? Okay. Is there a more efficient way we could do this? I'm feeling there's probably a more efficient way of moving the zeros to the right.
I think an issue with this solution though
Yeah.
is like let's say we have a 0 in the middle, so we have like 4 0 4 0, right? Something like that. Well, actually, like let's say we have 8 0 16 0. Actually, no, that works. Never mind.
Okay, so
I was just thinking if we were sorting it, but we're technically not.
you know what? Now that I think about it, what we could do is we could do then again, kind of don't want. Hey, Laz, what do you think we should do for this problem? 2048.
Yeah, I'm working on it too. I just broke it up, each move into each function.
Yeah.
And then 3 nested for loops. The outer for loop does it 4 times, just in case to push everything to the left or to the right or up and down.
Yeah.
And then the inner 2 just does the math.
Yeah, because what are you pushing? You're pushing the zeros to the right, or are you pushing the numbers themselves?
So if for one current index, the same goes to the left, right?
Yeah.
The current one I'm on is equal to the one behind it. I add, right? So this one times 2, and then this one's set to 0.
Right.
But then you have to take into account the fact where you got like 4 0 and 2.
Mm-hmm.
That's wrong. It should be 4 2 0 0.
Right.
So that's why I have that extra for loop that goes over it 4 times to push everything to the left, or to whatever direction you may move.
Right. Okay. We may or may not get this done today. Just saying that now.
Maybe we can let the solutions.
No, we're not gonna lose this. 2.5.
Just implementation.
Yeah, it's just this is an implementation problem. 9.0 is the hardest problem here.
9.0 is the hardest
Yeah.
problem. Can you like show the hardest problem? Just like
No, well, I mean,
it's just sneak peek at the end.
We're just coding this.
Iterative without Google.
George, do you know what to do?
No.
All right. So for each row, you're gonna let's see. So we're actually what I'm gonna do. I'm gonna make I equal to 0 and J 1. Wow. J less than 4. We know what the length of the board is 4. So if J 0 row J 0 J 1 going to the left, we want to flip. this is for a left move. So this is me basically getting all the numbers together and moving the zeros all the way to the end. Does this make sense?
Yeah.
Okay. Okay, no, actually, does it actually make sense?
Well, yeah.
Well, okay, explain it.
Okay.
Explain what I did.
All right. So what we're doing is that we're initializing our position on the board, right? We
On the
have
road,
I
to be
equals
specific.
0. What?
On the road, to be specific.
Right. Yeah. We have I equals to 0, meaning that we are on the first index, and j being 1, which is we're checking for the next one. So while j is less than 4, meaning we don't, as long as we don't go over the board, we check to see if it's 0. If it isn't, if it is, we move j
Up.
to the next index.
And why do we do that?
Because we're checking to see if there's another value after.
Right. Yes.
Okay.
Yes. And then we move that value to the
Back.
current zero. Yes. To the
Yeah,
left. Exactly.
exactly.
That's what happens.
Yeah.
Good job. So that's what we're doing. That's all that this really does. Yeah. Okay, because what if they were all zeros? Then now you do nothing. Yeah. And you break out of the while loop. So J is the one all the way to the end. J is ahead of I. That's the one we care about. We're moving in that direction. So we want to also check. So we want to make sure that if, let's say I is an actual non-zero, right? So we want to move J up. Actually, now that I think about it. I might have to move I up as well. Plus a J. Guess I have to move that up. Actually, that might be a little bit trickier. That actually might be tricky. No. Let me look at one of the examples that they give. Okay, so we want to turn this into this, into that. Okay.
Oh, I think this part's not as complicated. I think
No?
once we have it sorted, we just add the values on the left. So like we make I equal to
The first zero.
I plus j, right?
And then J.
Yeah, and then exactly, and then we
Okay, we just got to. I just had to. You have to see it, you know. You have to see it, otherwise. Exactly. So, actually, that has to go there. That'll still be zero. That'll still be zero. Yo, Ricky. You ever played 2048, Ricky? The game? 2048? Yeah, so we're implementing it. Yeah, actually not really. Implementations are kind of pain. But this one should work. So what I'm doing here is that I move I to the first zero, make J go ahead of I, and move J up, and then just find the next number. So J is here. And then while J is still less than the length, which is 4, just swap them. So
that makes sense.
So then we have to do this for like every
row, yes. Every row. Yeah. So yeah, I mean, there's probably a cleaner way of doing this if I'm being totally honest with you. But um, no, I'm not done. I have to do the. I have to. Well, okay. So I've done this part. Now I have to do this part. Yeah, it's interesting. Actually, now that I think about it, we are gonna do this again. Yeah, we may have to do that again afterwards. So let's say that we did this part, right? Well, let's for another example, and then we got. Let's say we get this, right? Yeah. So I'm gonna go make this 0, that is 8. I know. But how does it know? How does it know? How does the computer know that? We have to implement that logic. So then we have to do it again. We have to put it back. Fun stuff, right? So that's why I'm putting it again.
Oh my god.
Fun stuff.
This problem's rough, dude.
I know.
Jeez.
I know. Mm-hmm.
Yeah, homework for everyone. Do it yourself.
Yeah, guys. So if you want, you can do it yourself, and try not to repeat the for loops this many times. Maybe make it all into a function. Yeah, make that into a function. Don't do this because this is repeat because they don't like it when you actually repeat code. You don't need to repeat. If you can put it in a function and make it more shorter, that's even better. So yeah, yeah. So I think I could actually make this all one function. What? So let's say we take care of this, right? So how are we going to merge? For example, how do we merge this? Let's say we put I here, right? Yeah. So then I'm gonna I equals I plus J, right?
Yeah.
Okay. So I'm actually gonna do that again. Okay. So I
And
then that's not gonna
you
be
just need to add those two numbers.
yeah. You-
And then we can run a for loop that for any other numbers that come next, we add them as well. Like we can call a function that moves the zeros to the right. We call it so 4022 becomes 4220, and then we call the adding function again or something like that.
Let me see. Row I row doesn't equal. So while they're not equal to each other, 1 J plus equals 1. Does that make sense? While they're not equal. Then once they are equal, right? We have to merge it. Actually, we may have to put that in a. Let me see. I think we could actually put this here. Okay. Wow. So again, we have to put that in there. Okay. So now we found where I equals J, and presumably we're not out of bounds. Presumably. So what do? Right? if j is less than 4, then clearly we found a match, right? So we just say row I equal row j, row j equals 0.
Yeah.
Yeah.
What
Okay.
about row I is equal to row I plus 1?
Hmm?
So,
Actually, if we're at this point and we make this 0,
oh no, no, that's fine. Yeah,
we
yeah,
so we go to 8. So we have to move I not by only 1, we have to move by 2.
yeah. We check if there's a 0 in the next one, and if there is,
No.
then we go to the next index. Yeah, and then we do the comparison again.
Well, that's the thing. All the zeros are to the right, so we don't have to worry about that too much.
Well, but after we merge the two fours, there's going to be a 0 there, so we have to sort it again, right?
No, we don't. I mean, I mean, yeah, that's gonna be after. That's gonna be
Oh,
after.
okay.
So I'm gonna move I by 2 instead of just 1.
Okay. Oh, that yeah, because it's assumed that yeah. Okay.
I'm gonna do I plus 1. I'm just gonna do it again. A lot of pluses, I know. This isn't the most efficient code, but when you're on a yes, actually, yeah, I know. That's the thing. We just started this. Implementation problems are like a little bit like.
What was supposed to be like the plan before we went on doing
I was gonna go over a problem, but Lazaro said that he was working on it, so I decided not to. You solved it, but he solved it already. I know, but that problem's actually harder than this one.
No. This one's
Really?
taking me longer yet.
Yeah, right. You think this one's taking you longer?
For sure.
Because this is it's really just implementation.
This website's rough, dude. Holy
Yeah,
fuck.
I know. This leak code has been holding your hand thus
Oh
far.
my God.
So I don't think we have enough time to test it. We do
Yeah.
have somebody taking a doing a midterm here, right, using this room right now. So I'll encourage you guys to this part to make an account on Kattis, right, and solve it. Yeah, represent FIU. Up our score, up
Yeah.
our ranking in the universities. We'll rank 153. Put that at 100 at least. Nah, I'm kidding. I'm kidding. I mean, if you want, but, but yeah, you learn a lot. How to approach problems, and you don't even have to do like really hard ones. Just like the 2s and the 3s, the 1s. Those will get you ready for interviews. This is a 2.5. Yeah, this is an easier problem. But yeah, even the easier problems are like pretty hard on this website. So I do encourage you, challenge yourself a bit. And yeah, and next class meeting, we're gonna talk about merge case sorted list, which is just a follow on of what I talked about. All right. So yeah, thank you everyone for coming. Yeah. The what? The game? Oh yeah, yeah. Can you even install it? You can install it? Oh, I thought they banned it like Flappy Bird.
No, the creator of